Hello everybody, Root Beer here. We're going to be looking at another math contest, this time the 2006 Galois paper. Now the Galois paper is a grade 10 level contest. The written solutions are required, so you do need to justify your work. Okay, and if you'd like to try this contest for yourself, you can download a copy for yourself. Do it now, don't wait. Practice it on your own. You get 75 minutes. Calculators are allowed. So click the first link in the description, download a copy for yourself, try it out. Practice really does make perfect, guys. And then you can come back and take a look at any of the videos and see what you've missed or see maybe a new trick. I'll be doing question 1 in this video, but if you do question 1 and 2 and you don't have any problems till question 3, feel free to move ahead and watch the question 3 video. Okay? So, let's get to question number 1 here. A hat contains 6 slips of paper numbered from 1 to 6. Amelie, I'm going to say it's Amelie. Yeah. Amelie and Bob each choose 3 slips from the hat without replacing any of the slips. Alright. Each of them adds up the numbers on his slips. Is this a boy's name? They probably just forgot his or her slips. And looking ahead, yeah, they do refer to Amelie as a her. Okay, that's what I thought. Anyway, so we got 4 parts to this question. We do need to justify any calculations or assumptions or any intuition we have here. A. Determine the largest possible difference between Amelie's total and Bob's total. Explain how you found this difference. Okay. So, largest possible difference between the two totals. Well, if we go into our notepad, I think it suffices just to say something to the effect of, so to maximize the difference, and it doesn't have to say, they don't necessarily want Bob's highest or lowest, right? So to maximize the difference, we'll maximize Amelie's score and minimize Bob's score. This can be done by Amelie drawing 4, 5, and 6 for a sum of 15, and B drawing out of the hat 1, 2, and 3 for a sum of 6. The difference is thus 15 minus 6, which is 9. Alright. So that's part A down. Didn't have to say a whole lot there. And do keep in mind, each question on this contest is worth 10 marks. So question 1 worth exactly the same as question number 4. And since 4 is usually harder, try and complete the questions in order. That said, if you're just not getting 2 and you think you got a shot at 3, by all means do 3. But the point is, each question being worth 10. If I break it down into 4 parts, at best one of these parts is worth 3 marks, at worst one of them is likely worth 2 marks. So we don't want to give paragraphs and paragraphs of detailed explanation for A when it's only going to be worth 2 marks, maybe 3, although A parts typically are not the heavy hitters in terms of point values. So I'd bet A is probably worth 2, B is probably worth 2, and C and D are both worth 3. That's my guess here. Okay? So do we really need to explain a whole lot for A? No. You get the value of 9, and you explain just a little bit, we want to maximize this sum, minimize this sum. That's all. Nothing you have to stress about. Okay, so B. List all possible groups of 3 slips that Amelie can choose so that her total is 1 more than Bob's total. Okay. all possible groups of 3 splits. Now the slips of paper can only be 1, 2, 3, 4, 5, or 6. So if her total is one more than Bob's total, I'm going to give a name. I'm going to give a variable name. Let x equal Bob's total. And then Amelie, and I'm probably going to, as I did in the last question, I'm probably going to start doing A and B. It just saves a little bit of time. Then Amelie's total is x plus 1. And 2x plus 1 is the total of all the slips. And so that's 1 plus 2 plus 3 plus 4 plus 5 plus 6, and that's 21. So 2x plus 1 is 21. X is going to be equal to 10. So Bob's total needs to be 10. Amelie's total is 11. As soon as I can make her total be 11, we know the sum of all the slips is 21. Bob's will have to be 10. So we ask ourselves, how can I make Amelie's total 11? And there's not really a prescribed way we should go about doing this. Suppose that she has a 6. So she's got 6 and then 2 other pieces. So we'll call them x and y. No, I already used x. We'll call them, I don't know, y and z. Y and z. Y plus z is 5. So y plus z could be 2 plus 3 or 1 plus 4. So 1, 4, and 6, 2, 3, and 6 are possibilities. Are these the only ones? So we suppose she had a 6. And I chose 6 because 11's kind of big considering the numbers 1, 2, 3, 4, 5, 6. So I chose to narrow it down. What I figure we'll probably have to have a 6 or a 5. I don't think we'll be able to have a 4 because at best you'd have 4, 3, 2, and that's 9. But we can try 5 here. So suppose she has no 6, but has a 5. So she's got 5, y, and z. Well, then y plus z needs to be equal to 6. How can I do that using the numbers 1, 2, 3, 4, 5, 6? Well, I can't just use a 6 because then I need a 0. And I can't use a 5 because I've already used my 5. Okay? So that leaves me with 4 and 2. Or 3 and 3, but there's only one 3 slip. So 2, 4, 5 works 2. If she has no 5 or 6, she at best has 2, 3, 4, which has too small of a sum. Therefore, A could have 1, 4, 6, or 2, 3, 6, or 2, 4, 5. That's it. Those are the only possible groups of 3 that work. Alright. So we'll flip the page because we still have C and D to do, and I'm going to need a fresh sheet. Explain why it is impossible for Amelie and Bob to have the same total no matter which 3 slips they choose. Well, hey, I sort of use that's sort of an argument in B. I'm going to say, suppose it were possible. So Amelie's score and Bob's score are equal to some value We could call it, I'm going to use X, but if you're uncomfortable, because we already used X in B part, yeah, they're separate parts, but maybe you're uncomfortable about that. I don't know, call it C, call it S for score, call it N for number. Doesn't really matter. Then 2X is equal to the sum of all the slips, which is 1 plus 2. Hey, we've seen this argument before. But 21 is odd, so X will not be an integer. Thus, getting A and B to have a score of X is impossible. If you wanted an extra little line in there, because maybe you're worried that that's not clear enough, you could say the sum of the, since each of the slips has an integer, the sum of the slips must be an integer, so X must be an integer. But wait, 21 over 2 isn't an integer. Oh no, we got a problem. That little extra line could help. I don't think it's necessary. I think it's fine the way we've got it. Okay, and we're at the end of question number 1. If more slips of paper are added to the hat, numbered consecutively from 7 to n, what is the smallest value of n bigger than 6, so that Amelie and Bob can each choose half the slips, numbered from 1 to n, and obtain the same total? Explain why this value of n works. Alright, so each choose half the slips implies to me that n's got to be even. Now, to you, it might not. Maybe you'll say, okay, yeah, we could play the same game with 7, but we'll get as close to half as possible. But I don't think so. I'm going to stick with the half of the slips, so n's going to have to be even. It's going to have to be an even number of slips. Now, because of that, and because someone out there might think that's ambiguous, this brings up a good point. If you think there's some ambiguity in the statement of the question and what it's asking for, and there's a little room for interpretation, I assure you there is going to be a correct way to do it, and there is an intended way to do it, because these things are workshopped to death. I mean, they go over the contest a lot. But suppose we were worried about this half. What I would do is quite clearly state, because of the word half there, I'm going to assume n must be even. Okay? That way, if for some reason the contest had a really screwy interpretation, maybe this was translated from a French guy proposing the question, because we do get questions proposed in English and French, and the half just didn't come out the right way in the translation, which I assure you, again, doesn't happen. They translate back and forth. But for the sake of argument, suppose that's the way it was. You could recover a lot of part marks because you've said, this is the interpretation based on my native language, and so on. Okay? Might not be enough to get everything, but somebody might stop and reconsider. Anyway, I don't really think it matters for this one. I think the half, it's going to be pretty clear that it's n's got to be even. But just in the future, if you ever run into a problem where you think it's confusing and the wording isn't quite clear, reread it a couple times, because they rarely make mistakes. But if that's the case, well, so be it. So I'm going to say for A and B to pick half the slips, we conclude n is even, and all even numbers can be written in a particular way. I'm going to let n be equal to 2k. I don't know if this is actually going to be needed, but I've got it clear right from the start. Okay, so A and B will each pick k slips. So there's going to be two parts to this question. We're going to have to find an n so that this argument up here doesn't fail. The sum from 1 up to n is even, so in theory we could split. But just because the math says, oh, it's you added up 1 plus 2 plus 3 up to n, it's even, doesn't mean that we can split it exactly the way they want us to split it. That everyone gets k slips. So we're going to have to be a little careful. I don't imagine it'll actually be a problem. It's question 1 on the Hypatia. But just thinking through things logically, we have 2 things to do. Find an n so that 1 plus 2 plus 3 all the way up to n is even, and n himself is even, and also show that you can have A and B both pick k slips so that they add up to the same score. Okay, the 2 things we have to do. Probably worth 2 marks here. And maybe another mark for figuring out something in terms of n. So, suppose A and B pick k slips each and get the same sum, and again, I'm going to call it x. Then 2x equals the sum of the slips, which is 1 plus 2 plus 3 plus 4 all the way up to plus n, or plus 2k. I'm going to leave it as n right now, but maybe I'll need to use 2k to help me figure out how exactly to split it up into k slips. Okay. Now, this sum here comes up a lot. So I would like to make a little sort of side note. Things to look up if you've never seen this sort of sum: triangular numbers, because that's what these types of numbers are. 1 plus 2 is 3, 1 plus 2 plus 3 is 6, 1 plus 2 plus 3 plus 4 is 10. These are triangular numbers. There's something to look into if you've never seen this, this sum of 1 plus 2 plus, but there's also a formula. The sum of the first n numbers is always n times n plus 1 all over 2. So I'm going to make use of that fact. And if you didn't know it, it's something that it is possible to work out, but we're going to make use of this fact. So rearranging, I can get 4x is equal to n times n plus 1. So I need n times n plus 1 to be a multiple of 4, otherwise I can't solve for an integer value of x. Well, something I note is n and n plus 1 are consecutive. So one of them is odd. In particular, it has to be n plus 1, since n is even. But n plus 1, if it's odd, it contributes no factors of 2. So we must have 4 divides n. Okay? If that's the case, then I can get an appropriate x value. So instead of n being equal to 2k, let's let n be equal to 4m. Okay? Now, the most obvious candidate would be 8. That's the next multiple of 4 after 6. And we'll get to that in a moment. But if 4x is equal to 4m times 4m plus 1, then x is equal to m times 4m plus 1. Okay, so that will be the sum. They didn't actually ask us for the sum. What is the smallest value of n so that they can choose the same, get the same total. They didn't actually ask us for the total, but we're starting to explain why this n will work. So in theory, as long as I choose a multiple of 4, I should be able to split. So 8 is the next multiple of 4 above 6. So 8 is equal to 2 times, 4 times 2. So m is equal to 2. So we'd want x is equal to m times 4m plus 1, and that's going to be 2 times 9, 18. Can I represent 18 as a sum using just 1, 2, 3, using 4 of 1, 2, 3, 4, 5, 6, 7, or 8? Well, let's play around with it. I'll take off an 8. That'll leave me with 10, and a 5, a 3, and a 2 will do just fine. Okay? There doesn't have to be a particular way you figure that out, but as long as I can now say, we see that 8 will do. By the way, we've also shown, I think, now I guess we did use the assumption that n is even, but you could have 7 and 8, but then you wouldn't have them splitting in half. So I'll deal with that in just a second. So 8 will do if A picks 2, 3, 5, and 8, and B gets 1, 4, 6, and 7, and that adds up to 18 as well. So that's all we needed to do. We've got the 8. We've shown it works. Just for a second, let's see. N is equal to 7. 7 times 8 over 2 is 28. So we would need 2x is 28. X would be 14. We can add up to get 14. For example, 3, 4, and 7 for A. And B getting 1, 2, 5, and 6. That would work, but we don't have them both picking the same number of slips. And they're not each choosing half of the slip there. So that's why I would say 7 doesn't work. Okay? There's not half the slips, because you can't half 7 slips. Alright? So our answer is going to be 8. And that finishes off question number 1. Hopefully I've intrigued you a bit. And if you haven't tried the Galois, seriously, download a copy, practice it for yourself, and we'll see you guys for question number 2 in the next video.